let's assume we have a 4 centimeter tall object. And let's place a lens near it. If I put my object at 2 times the focal length, then what will end up happening is the image will be constructed on the other side with the same height and the same distance from the lens. So it's just a nice one to work with. So here's a focal point, F. I'll call it F1 though, because we're going to have 2 lenses in this problem. So just notice that my object is located at 2F. And that's just a special point for these diagrams. Let's send a ray into our first lens. And it's going to bend through the focal point there. As we've seen in the past. There will be another ray that's important that goes through the center of our lens. Okay, so our image is going to get constructed right about here. Now we want that image to act as the object for a second lens. Where do I want to put my second lens? So I'm going to put it, let's say right here. And I'm going to let it have a focal length of 5. Alright, so here's a focal point. F2. Here's another one. F2. Alright, now that image of lens 1 is going to act as the object for lens 2. Alright, so now we want to send rays away from the image toward our second lens. You just basically do the process all over again. Alright, so if this was our object, we would send a parallel ray toward lens 2. That would be one important ray. And what would happen to that ray? It would be refracted through the focal point, F2. Alright, we would also send a ray directly through center of our lens. And this would allow us to construct the final image. Alright, so let's write that this is the image of lens 2, but it is also the image of the whole system. Okay, so that's just one of the simplest cases that we can have. We can go through the mathematics of discovering exactly where that image would be located and how big it would be, what the magnification would be, and all that. Alright, so let's do an equation for lens 1. We'll do 1 over dO1 plus 1 over di1 equals 1 over f1. This is thin lens equation for lens 1. So we want to measure the distance from our object to lens 1. It's dO1, and it's 20 centimeters. We also see that the focal length of our lens is 10 centimeters, so we can plug those things in. When we solve that, we find that the image distance is also 20 centimeters. And that's going to be the distance from lens 1 to where our image was constructed. Now we want to do a thin lens formula for lens 2, but we're not going to be able to do it until we know the distance that the image is from lens 2. Okay, the image that was formed by lens 1 becomes the object for lens 2. So we really need to know this distance here. It's called dO2. So there's a formula that can help us find that, actually. And it has to do with the lens separation. So that distance there that I drew is the lens separation. If you look at the numbers on the number line, you'll find that it's 35 centimeters between the two lenses. So we want to use that because if you look at the distances below, you'll see that the distance of image 1 plus the distance of object 2 equals the lens separation. Okay, hope that makes sense. So we want to plug in we can solve 15 centimeters. Alright, now that we have that, let's do a thin lens equation. For lens 2. So we'll have 1 over dO2 plus 1 over di2 equals 1 over f2. Now we have the object distance. And we can see from the picture that our focal length for lens 2 is 5 centimeters. Let's find the final distance of the image. It's 7.5 centimeters. Alright, so one of the other things we'll want to find is the magnification. So let's do that down here. The total magnification will be the product of the magnification due to lens 1 and the magnification due to lens 2. We'll replace magnification 1 with DI1 over DO1, and then replace magnification 2 with DI2 over DO2. Alright, so let's see. DI1 was 20. DO1 was also 20. So we're going to get a -1 magnification out of that first lens. And then we'll multiply by -7.5 over 15. The final result, though, will be a +1/2 for the overall system, which does appear to agree with what we drew. The final image is half as big as the original object. If you wanted to go on to find the height of the final image, that would be h prime, it's sometimes called. And you could do m total times the original height of the object. So that would be h prime equals 1/2 the height of the object. Now our final object distance will be from the lens 2 to where our final image is constructed. So that's going to be DI2. So that final result you get is not from the first lens, it's from the last lens, the second lens.